Hello everybody, and welcome to the definition of a Newton post-activity. In this activity, we were trying to figure out if we could find a good definition for a Newton. Why is a Newton the size it is? And so we decided to try to figure out how much force it took in newtons to make a 1 kilogram object accelerate at 1 meter per second squared. Remember that prior to this activity, what we knew about the Newton is that it's the unit of force in the International System of Units. It's a capital M because it's named after Sir Isaac, right? So it's named after a person. It's a capital letter. And back when we first used it, I said that 1 Newton was about 0.2248 pounds. A little less than a quarter of a pound, right, of force. Well, why is it that size? I mean, how did scientists come to that? It doesn't seem like it's a very nice conversion, not just something you would just chosen. So why did they decide for a Newton to be the size that it is, a little less than a quarter of a pound? Well, we went and did this lab, right? And if we gather up everybody's results, we take a look at the Google form here. Right, here is the force everybody found. This was the force to make a 1 kilogram object accelerate at 1 meter per second squared. And as we look at them, you can see they're all pretty darn close to one another. Right? Pretty close, pretty close, pretty close. And we get to an average of 0.995. And if we go to 2 sig figs, which seems reasonable, right, we get about a 1.0. That's interesting. Right? And everybody's was pretty close to that too. There weren't very many, there weren't really much of an outlier here. A couple of hundredths here and there, right? Close to ones. So our average here is about 1.0. So it appears that it takes about 1 Newton to make a 1 kilogram object accelerate at 1 meter per second squared. And in fact, that's why physicists decided to make the Newton the size that it is. They actually chose the size of the Newton based on this definition. If you want to know how much is a Newton, how much force, well, it's the force that makes 1 kilogram object accelerate at 1 meter per second squared. Isn't that a strange definition? It's good as any other, though. It works out to be a little less than a quarter of a pound, right? But again, it's just what the definition is, right? And we saw that it works that way in experiment as well. Now, this does mean, though, that the Newton symbol, the unit for a Newton, is something that's a little new for us. It's actually what's known as a derived unit. What that means is that up till now, all of our units have been based on the basic units: kilograms, meters, seconds. Right? Individual ones sometimes, mass is in kilograms, time is in seconds, right? Position is in meters, or combination of those. Velocity units, meters per second. Acceleration units, meters per second, or meters per second squared. But now we have a new thing, this Newton. Well, if we use the definition here, a Newton is actually a kilogram meter per second squared. So this is the force required to make a 1 kilogram object accelerate at 1 meter per second squared. But physicists didn't want to walk around saying, hey, I applied this many kilogram meters per second squared of force, or I weigh this many kilogram meters per second squared. Right? So they decided to take that combination of units and give it a special name. And they decided to name it after Sir Isaac, since he did so much work with forces, and so they called it a Newton. So this is what is known as a derived unit. Okay? And we're going to see other derived units as we go throughout the year. And we're going to see other units that are just combinations of base units and without a name. Just kind of depends, right? As soon as they start getting complex, that's when they start giving them special names. Okay, but remember that all these mechanics units really are all combinations of kilograms, meters, and seconds. So once again, if you want to know how much force a Newton is, it's the force that is required to make a 1 kilogram object accelerate at 1 meter per second squared. A Newton is, in fact, a kilogram meter per second squared.